What is happening inside that cardboard box in your refrigerator? It's not simply getting cold. On the surface of that pizza slice, specifically within the tomato sauce, a slow chemical reaction is intensifying. Tomatoes are rich in an amino acid called glutamic acid. When the pizza cools and water slowly evaporates from the sauce, even in the cold, the concentration of these glutamate molecules increases. This is the source of umami, the savory fifth taste. The refrigeration process acts like a slow cooker in reverse, not adding heat but removing moisture, concentrating the very compounds that your tongue identifies as deeply savory. Simultaneously, aromatic compounds from herbs like oregano and basil, which are fat-soluble, have had hours to migrate from the plant matter and dissolve into the oils and fats of the cheese and toppings, creating a more homogeneous and complex aroma profile. But the sauce is only one part of the equation. The cheese on your pizza is not an inert substance. It's a microbial ecosystem that was paused, not stopped, by the heat of the oven. As the cheese cools, bacteria like lactobacillus, used in its creation, can reactivate, albeit slowly. These microbes continue their metabolic processes, breaking down remaining lactose and milk fats. This enzymatic action releases new, highly aromatic compounds. Molecules like diacetyl, which gives a buttery flavor, and various esters that contribute fruity notes are synthesized overnight. What you're tasting is the result of a living food continuing its journey of fermentation, producing a more nuanced and intricate flavor profile than it had just hours before. It's a microscopic flavor factory operating while you sleep. Beneath all this chemical activity, the very structure of the pizza is transforming. The crust undergoes a process called starch retrogradation. When bread is baked, the starch granules absorb water and swell up, a process called gelatinization, creating a soft, open crumb. As it cools over a long period, the amylose and amylopectin starch chains begin to realign themselves into a more ordered, crystalline structure. This process forces water molecules out from between the starch chains. This expelled water doesn't just disappear, it migrates, often into the sauce, preventing the crust from becoming overly soggy while making the crust itself denser and chewier. This gives cold pizza its characteristic firm, satisfyingly leathery texture, a stark contrast to the often floppy nature of a fresh slice. The migration of moisture is also a vehicle for flavor. Think about the garlic. When first cooked, its sharp, pungent compounds are highly localized. Overnight, water-soluble flavor molecules from the garlic, onions, and peppers are drawn out and distributed more evenly throughout the sauce and cheese via the migrating water. The fat-soluble compounds are doing the same, leaching into the pepperoni grease and cheese fat. This process, known as flavor melding, blurs the sharp edges between ingredients. Instead of distinct bursts of flavor, you get a unified, harmonious chord, where each component is harder to distinguish, but the overall taste is richer and more cohesive. The pizza has become more than the sum of its parts. So, the pizza has chemically and physically changed. But why does your brain perceive this as better? The answer lies in a phenomenon called hedonic adaptation. When you eat a hot, fresh pizza, your senses are bombarded with intense, distinct signals. Sharp tomato, salty pepperoni, creamy mozzarella. Your brain quickly adapts to these strong, separate flavors. The next day, the pizza is a different beast. The flavors are melded, the texture is chewy, the temperature is cool. This new set of sensory inputs violates your brain's prediction and stored memory of what that pizza should taste like. This is an expectation violation. When the new experience is still fundamentally pleasant, the brain registers it as a positive surprise. This novelty can trigger a small release of dopamine, the neurotransmitter associated with reward and pleasure, literally making the experience more enjoyable because it was unexpected. Ultimately, the leftover pizza isn't just a food. It's a new experience created from the old one. Your brain isn't just processing taste. It's performing sensory integration. The tactile sensation from the firmer, chewy crust is processed by your somatosensory cortex. The deeper, melded umami and aromatic notes are processed by your gustatory and olfactory cortices. The coolness is a signal from thermoreceptors. All of this data flows to the orbitofrontal cortex, the brain's flavor control center, where it's combined with your memories and expectations. Because the inputs are so different from the hot pizza experience, but cohesively pleasant, your brain constructs a new and subjectively better perception of flavor. The magic isn't in the pizza alone, but in the conversation between the changed food and your predictive brain.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.